Please title these notes Derivatives 9 Notes, Numerical Derivatives, and write today's date. At the end of this lesson, you should be able to find the value of the derivative at a given value for x, both with and without a calculator. This is what we were estimating from the graphs in Unit 1, and this is the major point of doing all this work with finding the equation for the derivative, is so that we can find the derivative at a particular value. So let's start off with a problem. Let's say our first problem is that we know that f of x is 3x squared minus 4. And we want to find f prime of 2. What this means is it means find the value of the derivative when x equals 2. Same idea as what we were doing in terms of trying to find the slope of the tangent line on a graph when x equals 2. So the first thing that we're going to do is we're going to get the equation for the derivative. Then all we're going to do is take 2 and plug it into that equation. Don't plug in this 2 until after we find the equation for the derivative first though, because if we plug in the 2 right now, we're just going to get that f of 2 equals some number. And the derivative of that number is always 0, which isn't what we want. We want to do the derivative first and then plug in 2. So let's start by finding the derivative. This is a pretty basic one. We bring down the 2. 2 times 3 is 6. Subtract 1 from the exponent. 2 minus 1 is 1. That's an invisible 1 right there at 6x. Derivative of negative 4 is just a constant, so the derivative of a constant is 0. And there we go. Now all we're going to do is take this 2 and plug it in for x, so f prime of 2 is 6 times 2, or 12. Bink! All there is to it. Where it gets slightly more complicated is if you have things like this. Let's say f of x equals the cosine of x, and we want to find f prime of 2 pi over 3. So we want to find the derivative when x is 2 pi over 3. This is where it's really important to have that lesson from the first unit down, where you're able to find the value of trigonometric functions by hand. So first we're going to take the derivative. We just kind of have to remember sine, cosine, negative cosine. So the derivative of cosine is negative sine of x. We said we want x to be 2 pi over 3, so the derivative when x is 2 pi over 3 is going to be negative sine of 2 pi over 3. Now we just have to be able to find that by hand, so we sketch our angle. This is 2 pi over 3. Our reference angle is pi over 3. The side across from pi over 3 is root 3. Hypotenuse is 2. This side is 1, but it's going in the negative direction, so it's negative 1. Sine we know is opposite over hypotenuse. We've got that negative along for the ride. And there we are. It's not too bad, it's just you have to remember how to do this. So let's give another example with trigonometric functions, just because those ones can sometimes be a little tricky. Let's say that f of x is the cotangent of x. We want to find f prime of 5 pi over 6. Now, we got to remember what the derivative of cotangent is. You just got to have it memorized. There's no way around it. F prime of x, we look at our notes from the previous lesson, derivative 6. The derivative of cotangent is negative cosecant squared. Just got to know it. And we also have to remember that the cosecant is 1 over the sine. So what we have here is that f prime of x is the same as saying negative 1 over sine of x squared. Remember, this cosecant squared x is the same as the cosecant, that whole thing of x, whole thing squared. So when we're saying 1 over sine of x, that whole thing is going to be squared. So now if we're trying to find the derivative when x is 5 pi over 6, 5 pi over 6 is right here, pi over 6 is our reference angle, the opposite side is 1, hypotenuse is 2, adjacent is root 3 but in the negative direction. So we're going to do negative 1 over the sine is the opposite over the hypotenuse, and that's squared. When we square that, we've got negative 1. 1 squared is 1, 2 squared is 4. And now we remember that when we divide by a fraction, that's the same as multiplying by the reciprocal. Our value there is negative 4. Some of these get a little bit nasty to do by hand, but it's still important to be able to do them because half of the AP test doesn't permit you to use your calculator. So let's try one that looks a little bit ickier. So let's say some function g of x is the natural log of x over 3x squared. And we want to find the derivative when x equals 4. So the first thing to notice is that we're going to have to use our product rule. Again, don't get confused by this g here versus this g here. This is just saying that top and bottom, and the bottom. So we start off with finding just the plain old derivative of x. We're going to have to do the derivative of the natural log times this right down here. Then we're going to subtract the top, derivative of the bottom, all over the bottom squared. Looks kind of nasty. Let's simplify it a little bit before we put the numbers in. Derivative of natural log is 1 over x times 3x squared, and then minus the natural log of x just stays there. Then when we take this derivative, bring down the 2, 2 times 3 is 6, x, 2 minus 1 is 1, so we have an invisible 1 there. And then here 3x squared, we square the 3, that's 9, square the x squared, that's x to the 4th. Now we're ready to put in this 4 for x, so g prime of 4. We notice here that this can be simplified a little bit. With this x cancels out one of the x's there, so this is just 3x. X is 4, so 3 times 4, minus the natural log of 4, 6 times 4. Here we have 9 times 4 to the 4th. G prime of 4, 3 times 4 is going to be 12. Nothing we can do with that natural log of 4 without the calculator, so that's just going to stay put. 6 times 4 is 24. Then down here, this is going to be a little bit of a pain in the butt to work with, but we do know that 4 times 4 is 16. So if we just multiply 16 times 16, that's going to give us 100, 60, 60, 36, 256. And then we take that 256 and we multiply times 9. Okay. When we multiply that out by hand, should get g prime of 4 equals 12 minus 24 natural log of 4 all over 2,304. I have a sneaking suspicion these may all be divisible by 12. Let's check. 2304. Divide that by 12. 12 goes into 23 once, minus 12 gives us 11. Bring down the 0. Let's see, 12 goes into 110 9 times. So minus 108. Bring down the 4. 12 goes into 24 twice, 192. So this is nice. 12 is divisible by 12, so that's going to give us 1. 24 is divisible by 12, that's 2 times the natural log of 4. And then 2,304 divided by 12 gives us 192. Without a calculator, we can't go any further with that natural log of 4 there, so we just leave it like that. Make sure when you're dividing 12 by 12, anything divided by itself is 1, not 0. You're still going to have the same number of terms here that you do here. Let's give you a check for understanding problem now. If h of x is 2x squared over the cosine of x, I want you to find the derivative of h of x when x is equal to pi. Try that one on your own or restart the video when you're ready. Pause the video now. Okay, so first thing we got to do is take the derivative. We're going to use that quotient rule, derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Now we're going to take those derivatives, bring down that exponent right there. Derivative of cosine is negative sine. Now we're going to figure out what happens when x equals pi, so we plug in pi for each of the x's. 4 pi cosine pi, 2 pi squared times sine of pi. Notice these negatives got together to be a positive. Cosine pi squared. So I put my little drawing of the angle pi. I remember that cosine is x, which is negative 1, sine is y, which is 0. So wherever I saw cosine of x, I put in negative 1. Wherever I saw sine, I put in 0. So here we have negative 4 pi plus this multiplies to be 0 over negative 1 squared, which is 1. And when I add and divide that out, I should end up with negative 4 pi. The final thing that we're going to look at is how to use your calculator to do a lot of this for you, because half the test permits the calculator, and it's really, really, really helpful as a shortcut. Also, there are some problems that simply can't be done analytically or using algebra. You have to do them using the calculator. So, on the calculator, to find the numerical derivative, you're going to go to Math, 8, which takes you to the command n deriv. So you're looking for that. And here's what the entry is going to look like. You're going to have n deriv. That's going to open parentheses for you. Then you're going to enter the expression followed by the variable followed by the number. So the expression is the original expression. The variable is just whatever letter you're using over here. Normally it's x. And the number is the value you want to take the derivative at. So for example, let's just use the same problem that we used right at first in our notes. We're going to find f prime of 2 if f of x equals 3x squared minus 4. And we've already done that, so we know that the answer that we should get should be 12. So what I'm going to do is I'm going to get out my calculator. And I'm going to go to Math, and then arrow down, number 8 is the end deriv. So the function that I want to put in is 3x squared minus 4. So I'm going to type in 3, then my x is right here, squared is right over here, minus 4, comma. I'm going to put in my variable, which was x, so I'm just going to hit x, comma, the number I want to evaluate it at. I wanted to find f prime of 2, so I'm just going to put in 2 right there and close the parentheses. Then when I do that, voila, I get 12. The one downside to this, although it's a very, very powerful tool, is it will only give you answers in decimals. So let's say we wanted to do the second one that we had originally right here, find f prime of 2 pi over 3 when f of x equals cosine x. We can do that, but it's not going to give us the same answer. It's going to give us a decimal. We just have to check and make sure that that decimal is the same as this number here. So let's do that second one. Oh, here's our answer. F prime of 2 equals 12. Yay! Our second one, if f of x equals cosine of x, find f prime of 2 pi over 3. First thing you want to do is make absolutely sure your calculator is in radians, so go to Mode. This radian should be highlighted. If it's not, arrow down to radian and hit Enter. And then second Quit will bring you back to the main screen. So we're going to go back to Math, that button right there, 8, and we're going to put in our cosine of x. Our variable was x, and then we wanted 2 pi, the pi button is right there, 2 pi divided by 3. Close up parentheses. And so that gives us negative 0.866. If we want to make sure that our answer back over here is right, we're just going to have to put in negative square root of 3 divided by 2. Look, it gives us the same thing. We're getting the same thing now. So, what I want you to do for a check for understanding is I want you to do the same problem that we did for the check for understanding problem right over here. If h of x equals 2x squared over cosine x, I want you to find the derivative when x equals pi. Go ahead and try that one on your own. Start the video again when you're ready. Pause the video now. Okay, so what I'm going to do is I'm going to go to Math 8. I'm going to put in 2x squared divided by cosine of x. My variable is x, and I want to evaluate it when x equals pi. When I put that in, I get that h prime of pi is negative 12.566. If I come over to my other problem, I got the exact answer of negative 4 pi. Let's check and see. Negative 4 pi gives us the same answer. That concludes the notes for derivative 7.